Number 10. Which of the following nuclei lie within the band of stability? And then we have oxygen-16. Okay, so is oxygen-16 a stable isotope? Or would it be in the band of stability? Or is it unstable? Would it not be in the band of stability? Well, let's see. In order to find out whether something's going to be in the band of stability or not, you have to first find out the total number of protons and neutrons that the isotope has. So let's just write that out in nuclide notation, right? Where we have O being oxygen, and then generally speaking, we have a number on the top and a number on the bottom. So we just have to find out those two numbers. Now, keep in mind that the number that's always going to be next to the element, right? So oxygen-16, carbon-12, carbon-14, nitrogen-14, right? Any of those numbers, this number, is always representing the atomic mass. And the atomic mass is the mass of the nucleus, which has both protons and neutrons included. So we know that because it's oxygen-16, we got 16 total protons and neutrons, but we still need to find out how many of each. And just know that the bigger number is the mass number. That's the number that goes on the top. But now what about the number on the bottom? Well, the number on the bottom of the notation is always the atomic number. And the atomic number is always specific per each element, right? Every element will have its own unique atomic number, and that's always the number of just the protons. But how do I find out what the atomic number of oxygen is? Good question. We gotta go to the periodic table. Do you have yours out? Whip it out. If you don't, right? I have mine right in front of me. We look for the lower number. It's the whole number right next to oxygen, and that is number 8. So oxygen will always have 8 protons. It will never, ever, ever change for oxygen. So we know that we have 8 protons. But now how are we going to find out how many neutrons we have? Well, if the mass is protons plus the neutrons, and the 8 is just the protons, yeah, you got it. We can subtract the two numbers to get the number of neutrons, and 16 minus 8 is 8. So we know that we have 8 and 8. Now, we might be able to do this question without looking at the band of stability. You should know your magic numbers. And 9 times out of 10, if you can find out a magic number, right, as your protons and neutrons, then that isotope is going to be stable. And if you have double magic, that's a really, really, really stable isotope. And look, I see an 8, right? These magic numbers are just because of these filled, they go with like the filled octet, not the filled octet, but the filled electron subshells. It's the same kind of idea, where you have a total of 2 in your s orbitals, or your 1 value and then your 2 value here, where there's 20 total electrons in your 3's principal quantum number. It kind of has the same exact idea here. But since we both have an 8 and a double 8, we don't even have to look on the graph. This is double magic. Double magic. And, if you have double magic, did I spell magic right? No, I didn't. G. If you got double magic, that basically means that this is going to be the most stable isotope out of all the oxygens. And it is. Oxygen-16 is the most abundant oxygen in the world. So we would say, yes, this is totally within the band of stability. And that's it. What'd you think? Hopefully this helped. Let me know in the comments. Love talking to you guys. And I hope you're having a great day out there. It's almost the new school year. I get so excited around this time, making schedules. I remember making my school schedule. That would make me so happy. Just having the plan, right? But anyway, thank you so much. We opened up memberships for anyone who wants to help channel out a little bit more. Thank you so much for that, and I'll talk to you soon. Okay, bye-bye.